All right, good morning. So today we are doing 2 well, I guess it's not morning, but right now we're going to do 2.5 on Algebra 2, and it is 1.6 in pre-calculus. Okay, so 2.5 if you're in Algebra 2, and this is the Apex version. Okay, so we're going to be talking about systems of equations. So a system of equation is two or more equations with the same set of unknowns. In other words, it's several graphs that are graphed on the same coordinate plane or the same coordinates. So usually right now we're going to be talking about lines, but we'll get into graphing with other um, with lines and parabolas, and then later on even circles and different shapes. But when two lines intersect at a single point, the system of linear equations has only one solution, that single point where they intersect. When two lines don't intersect, they're never going to touch, so they have zero solutions or no solutions. Okay. And when two lines coincide, the system of linear equations has infinitely many solutions. Okay, in other words, if two lines coincide, they're the exact same line, and we're going to talk about that a little bit more over here. Okay, so we have parallel lines. Okay, we know that parallel lines have slopes that are the same. However, their y-intercepts are different. Okay, but lines that coincide have slopes that are the same and y-intercepts that are the same. In other words, they are the exact same line. Okay, but you may not see that right away because they may be written in different forms. Okay, one may be written as a point slope form. So, I may say, well, y minus 3 equals 2x minus 26. And the other line I may give you is y equals 2x minus 23. Well, these really do coincide, because if I solve this and put it in this format, then I get the same answer. Okay. All right, so let's go on ahead and give an example of a system of linear equations that has each of the following numbers of solution. So one that has infinite many. So this is a pair of lines that coincide. So that would be my, y minus 3 equals 2x minus 26, and y equals 2x minus 23. Okay, they're the exact same line. Okay, so exact same line. Okay. Lines that have zero intersections have to be parallel. So it could be any two lines that have the same slope. So I'm just going to say 3x, but the lines have to have different y-intercepts. Okay. Because these are never going to touch because they're going in the same direction. Okay. And then our last one here would be one intersection, and it's going to be all other lines, whether they're perpendicular or just have some sort of slope. So if we say 3x plus 4 and y equals, I don't know, we'll say 2 over 3x minus 7. Doesn't matter what the slopes are. If they're not the same, they're going to touch at some point somewhere, even if it is, if we were to graph it, if we would have to go out to x equals 1,000. Okay, at some point they're going to touch. Okay. So we have three methods to solve the system of equations. Our first is graphing, our second is substitution, and our third is elimination. Okay, so we're going to talk about all three of these methods. Okay, so method one is graphing. Okay, so when we solve using graphing, we're going to graph both points on the same equation or on the same graph, and we're going to see where they intersect. Okay, so I'm just going to graph this line right here first. Okay, so here's my solution, my system of equations for number one. So my y-intercept is 0, -3, and my slope is +1. Okay, so mine are never exact. So please forgive my lines. I don't get rulers out too terribly often. All right, so there's my line. So y equals -1/2 x plus 3 is my other line. So my y-intercept here is 0, 3. And my slope is -1/2. So remember, that's -1 over +2 or 1 over -2. Okay, so I'm going to say -1 over 2 because I know that they're going to intersect somewhere over here in this direction. Okay, so 1 over -2, 1 over -2, and you can see that my line was a little bit off here. I'm going to fix that so that it looks prettier on my other line. Okay, so here, then I would be able to draw my line. Okay. So this point right here where they intersect is going to be my answer. So I have to write my solution as a coordinate. So my solution here would be 4, 1. That is my answer. So let's go on ahead and do this next one. So I'm going to graph this first line. My y-intercept is 0, 4, and my slope is -2 over 1. Or up to back 1. Okay, and once again, it's probably not going to be too exact because, well, I'm not a very exact person when I draw by hand. So here's my next one. My y-intercept is 0, -3, and my slope is up 1 over 3. Okay, up 1 over 3. So now if I connect those lines, okay, or I draw both of those lines, they're going to intersect at the coordinate 3, -2. So that is my solution. That is where they touch. So let's take a look at 2 more example problems. So this one right here, another one where I just have to graph it. 0, -1 is my y-intercept, and up 2 over 1 is my slope. So I'm going to go down to back 1 a couple of times. If I can see, all right. And let's see how straight I can get this line. All right, and then I'm going to have y equals -x plus 5, so +5. And remember, this is -1 over +1 or 1 over -1. So I'm going to go -1 over +1 a couple of times, and I can see I've already crossed it. So my solution, my answer to this problem would be 2, 3, the coordinate 2, 3. Okay, so now this one is a little bit different because it's in a different format. So in order to graph this, I have a couple of options. So for this first one, I'm just going to show you one of my options would be to find the x and y intercepts. So I could plug in a 0 for x and a 0 for y and find my x and y intercepts. So if I plug a 0 in for x, then I get -y equals 2. So -y equals 2, which means y equals -2. Okay, so my y-intercept then is 0, -2, and I would graph that point. Now for my x-intercept, I'm going to plug y in for 0. Okay, so that's going to be a 0. So that's going to be x equals +2. Okay, so now I'm given 2 points, and I can graph them. Now the problem with this is if I don't use a slope and stuff, sometimes it can be hard to tell where these actually cross. But as you're going to see when we get on to our next 2 methods, it's not a good idea to use graphing anyways, and we don't use it much because it's hard to tell where they cross unless it's exactly on some crosshairs. And even then, if your lines aren't exactly straight, then you're not going to be able to see it. Okay, so now this one right here, I'm going to go on ahead and just solve for y because it looks like it's going to be the easiest way. So this one, I'm going to get y equals -2x plus 1 because that was really easy to just solve for y. So I can just graph this one normally, and I'm going to go down 2 over 1, down 2 over 1. Okay, and you can see that these cross at 1, -1. Okay, so when you're graphing these, remember that you can graph it this way. That works just fine. You know, if I'm not asking you for a slope or anything, all you need is 2 points to graph a line. Okay, but once again, we don't use graphing much because it is not very accurate. So the 2 methods that we do like to use are substitution and elimination. So let's talk about this. So substitution. So substitution is really good if one of your equations has a y equals or an x equals, or like this one right here, if it is really easy to get into that form. Okay, because what we're going to do is we're going to replace one of the variables in an equation with that other answer. So let's go ahead and take a look at some of these problems. So here I have an x equals y plus 4. What that means is anywhere in this equation I see an x, I'm going to plug y plus 4 in. So it's kind of like that, you know, when I have equations that say f of 2 equals, 3x plus 7 or whatever it is, right? I'm just plugging this 2 in anywhere I see an x. Well, same thing, I'm just plugging this y plus 4 anywhere I see an x there. So 2 times parenthesis, don't forget that parenthesis, y plus 4 plus y equals 5. So now I have to distribute, okay, and I'm just going to solve for y like normal. So 2y plus 8 plus y equals 5. So I get 3y, combining my y's, I like terms, plus 8 equals 5. Subtract 8 from both sides. 3y equals -3, which means y equals -1. Okay. So if y equals -1, now I need to go back and I have to solve for my x. Okay, so I can solve for my x by plugging my y back into either equation. In this case, I'm going to choose the bottom one because it looks like the easier one to plug it into. So x equals -1 plus 4. So x equals 3. But remember, this isn't my answer. Okay, I will count you wrong if you do that. Most teachers will. Okay, it has to be a coordinate. It's 3, -1 is the solution. That is where those two lines cross. Okay. Let's take a look at the next one. So the next one has a y equals and some stuff. So anywhere I see a y in this other equation, I'm going to plug that stuff in. So x plus 4 times -x plus 3 equals 6. So x, now I'm going to distribute, okay, minus 4x plus 12 equals 6. Okay, so x minus 4x is -3x plus 12 equals 6. Subtract 12 from both sides, and I get -3x equals -6. Divide both sides by -3, and I get x equals 2. But remember, I'm not done yet. Now I need to solve for y. I can plug my x back into either equation. I'm going to go ahead and plug it back into the top one. Now keep in mind, this is a -x. So it says y equals -x plus 3. Okay, that means negative whatever my x value is plus 3. I had some students that get confused on that all the time, okay? Because if this was a negative sign and this was a negative, okay, then a lot of times they wouldn't remember to replace it as a positive. Okay, so the x is completely separate from this negative. This negative is like saying -1 times x. Okay, all right, so y equals -2 plus 3, which is 1. So my solution is 2, 1. The coordinate 2, 1. Let's take a look at the next one. So the next one, same thing. I have it already in a y equals. Okay, I can easily plug this in. So anywhere I see a y, I'm going to plug 2x plus 8 in. So 3x plus 2 times 2x plus 8 equals 9. So I have 3x, oh, not equals, not yet. So I'm going to distribute this 2, so I get plus 4x plus 16 equals 9. That's 7x, and I got to subtract 16 from both sides. I'm kind of starting to combine stuff on you guys. Okay, so 9 take away 16 is -7. Divide both sides by 7, and x equals -1. Now I'm going to plug that -1 back into either equation. and solve. So y equals 2 times -1 is -2, plus 8 is 6. So my answer is -1, 6. All right, so my last one that I'm going to do substitution for today, x equals 4y plus 11. So anywhere I see an x in the other equation, I'm going to plug in 4y plus 11. So I get 4y minus 5 times 4y plus 11 equals 9. So I'm going to distribute this -5. So I get 4y minus 20y minus 55 equals 9. I need to combine my like terms. 4 minus 20 is negative, let's see, 16y. Okay. And then I'm going to add 55 to both sides, if I can write, and I get equals 64. So now divide both sides by -16, and I get y equals -4. I'm going to plug this back into either equation. So x equals 4 times -4 plus 11. So x equals -16 plus 11. So that's going to be x equals -5. So my answer here is going to be -5, -4. How could you check to see if this is right, okay, or if you've gotten the right answer? You can check any one of these. All you have to do is take the x and the y and plug it into the first equation, and you need to plug it into the second equation. You have to make sure they work in both equations, okay? But that's a good way to check your work and see if you're right. Okay, so with substitution, elimination, even with graphing, you can plug them back in to both equations and see if they work. Okay, so let's just do this one. So x, so if I put -5 equals 4 times -4 plus 11, right, then I should get -5 equals, well, that's -16 plus 11 equals -5. And the same, if I were to plug it in here, I would get this side 9 equals 9. Okay, so you have to make sure it works in both equations though, because sometimes they'll work in one and not the other. Okay, so be really careful about that. Our last method is elimination. With elimination, we're going to actually get rid of one of the coefficients, either x or y, by adding the two equations together. If adding the two equations doesn't eliminate a variable, then we're going to have to actually make over our equations by multiplying the equation by a number. And we'll do, examples of both. Okay, so let's take a look at an example. So here, these two, I'm going to add these two equations and hopefully get rid of something. So in other words, I'm combining like terms. When I combine my y terms, I have a positive 7y and a negative 7y. Okay, so those are going to cancel out. Positive, 7 pins, and I take 7 pins away, I have no pins left. Okay, so here I'm going to combine my like terms here. So -4x's and 5x's is 1x equals, and I'm going to add these two. So 30 plus -34 is -4. So I get x equals -4. Okay, done. But now I have to find my y. So in either one of these equations, I'm going to plug -4 back in. So I get -4 times my x value, which is -4, plus 7y equals 30. -4 times -4 is 16, plus 7y equals 30. Subtract 16 from both sides, and I get 7y equals 14. Divide by 7, so y equals 2. So my answer, once again, is still a coordinate, okay, of -4, 2. And remember, I could check it by plugging both my x and y back into both equations and making sure they work. So let's take a look at this one. So this one right here, I have a 4x and a 7x. I have a 3y and a -6y. Well, I can't get rid of either one of them as they sit, but I always look for the lowest number. So my lowest numbers here are my y values. 3 and 6 are less than 4 and 7. So I'm going to see, okay, if I count by threes, what is the first thing that 3 and 6 have in common? If I count by threes and I count by sixes, well, they both have 6 in common. So I'm going to try and make both of these coefficients be the same value with opposite signs. So here they're already opposite signs, so I don't need to worry about that. But this 3 needs to become a 6. And in order for that to do that, I have to multiply it by 2. But remember, I never just multiply one thing by 2. Anything I do to one term, I have to do to every single term. So the whole equation there has to be multiplied by 2. So when I do that, I'm going to get 8x plus 6y equals, let's see, 19 times 2 is 38. Okay. And then this other equation, okay, I'm just leaving the same. Okay. And now I can add those two and combine my like terms, and those y's go away. So now I have 15x equals 15. Divide both sides by 15, and I get x equals 1. Okay, now I'm going to plug my x back in. I'm just going to choose my top equation. So 4 times 1 plus 3y equals 19. Okay, so I'm going to get 4 plus 3y equals 19. Subtract 4 from both sides. 3y equals 15. And when I divide, I get y equals 5. Okay, so my answer is the coordinate 1, 5. Okay, you guys got to write these as coordinates. And we're going to do a couple more elimination problems that are just a little bit more difficult. And then we'll also look at a couple of inequalities. Okay, so, oh, and a word problem. So here's another problem. So once again, my x's are not the same and my y's are not the same. I'm going to choose my y's because my coefficients are smaller, so it makes it smaller numbers I have to work with overall. But in this case, I have a 2 and a 3. So if I count by 2's, right, it's going to be 2, 4, 6, 8. And if I count by 3's, it's 3, 9, 12. Hey, 3, oh, I missed a number. 3, 6, 9, 12. Okay, so 6 is the first number these are going to have in common. Okay, well, my signs are different, so I don't even have to worry about that. But this top one, I have to multiply by 2 to get it to equal a 6. And this bottom one, I have to multiply by 3 to get it to equal a 6. So now I'm multiplying both of them by something. Okay, so here I'm going to go 2 times 2 is 4x minus 6y equals 40. And I have 33x plus 6y equals -3. Now, keep in mind, if these signs were the same, I would just have to make one of these a negative that I was multiplying by. Okay, so that's all I would do to adjust that. Okay, so now we're going to go ahead and combine like terms. So 37x, that goes away, equals 37. Okay, divide on both sides, and I get x equals 1. All right. Sorry, I'm looking for my answer key just to make sure some of these, I just want to double check that I haven't made a math error here. All right, and then now I'm going to take this x equals 1 and I'm going to plug it back into either equation. Okay. So now I have 2 minus 3y equals 20. Subtract 2 from both sides. -3y equals 18. And now I have to divide both sides by -3. And I get y equals -6. Okay, so my answer then is the coordinate 1, -6. All right, let's go on ahead and work this last problem. Why don't you guys try it on your own and then come back and unpause it, and we'll see if you got the same thing I did. All right, so hopefully you guys work this out on your own. Well, if I look at my y's, I can see that they are exactly the same and opposite signs, so I can go on ahead and just start combining my two equations. So 5x plus 2x is 7x, negative 36 plus 15 is negative 21. So I'm going to divide both sides by 7, and I get x equals negative 3. Then I'm going to plug this negative 3 into either equation. In this case, I'm going to choose the bottom one just because I like working with smaller numbers if I can. So 2 times negative 3 plus 3y equals 15. So that's negative 6 plus 3y equals 15. Add 6 to both sides. 3y equals 21. So y equals 7. So my answer then is the coordinate negative 3, 7. Okay. Now let's go ahead and take a look at this next one. This next one is a word problem. So I have 3 pairs of jeans and 6 shirts equals $104.25. So I'm going to write out my system of equations. So I have 3 jeans, so that's a J. I'm just using a J for jeans, plus 6 shirts, and I'm not using an S because, well, I don't like to use S's because they look like 5s. So I'm just going to use an H. Okay, you could use X's and Y's or whatever you want. So plus 6H equals 104.25. And then 4 jeans plus 5 shirts equals 112.15. And we want to find the cost of each pair of jeans and each shirt. Okay, so let's take a look. On this one, I'm going to use the jeans because the numbers are lower, and I'm going to have to multiply. Okay, so 3 and 4, the first thing they have in common is 12. So I'm going to have to multiply this by 4 and this by 3. However, one of them I need to change the sign on. I'm just going to do it on the bottom. It doesn't matter which one I do it on. Okay, so now I'm going to go on ahead and multiply that out. So 3 times 4 is 12J plus 4 times 6, 24H equals, and when I multiply this out, I get 417. And now I'm going to multiply negative 3 to everything here. So I get negative 12J minus 15H equals negative 336.45. So now I'm going to combine my equations by adding them together. So those will cancel. 24 minus 15 is going to be 9H. And 417 plus negative 336.45 or minus 336.45 is 80.55. I'm going to divide both sides by 9, and I'm going to get H equals 8.95. In other words, one shirt is $8.95. Okay. So shirts equal $8.95. Now I have to figure out what my jeans equal, so I have to put this back into one of my original equations, and I always like to go back to the original because they're smaller. So I'm going to say 3J plus 6 times 895 equals 104.25. Okay. So now that's going to be 3J plus 5370. Sorry, I know I'm a little crooked, being left-handed sometimes. All right, let's see. All right, 5370 equals, what does it equal? Oh, equals 104.25, duh. All right, so now I'm going to subtract 5370 from both sides. Yeah. And I'm going to get 3J equals 50.55 and divide both sides by 3. So I get J equals 16.85. So I know now that jeans equals $16.85 a piece. Okay. So in this case, I don't have to put it in as a coordinate because even though it is a coordinate, I just wanted to know the cost of a pair of jeans and the cost of each shirt. And so our last part here is going to be the solution to a system of linear inequalities. We're going to do this exact same way we did linear inequalities before with just one line. Okay, so the first thing I'm going to do, I'm going to look at this solid line first. Okay, so with this solid line, I know it's going to be y. It's graphed above the solid line, or it's shaded above the solid line, so it's going to be greater than, and it includes it because it's solid, so greater than or equal to. Okay, now I need to find my y-intercept, which is 0, 1. So that's going to be a positive 1, and now I need to find my slope, so that's up 1 over 1. Okay, so y is greater than or equal to x plus 1. Okay, I'm going to go ahead and draw my little bracket here that says it's a set. Okay, or a system. So now I'm going to look at this other one. So this other one is a dashed line, and we're shaded above the dashed line. So that means its y is going to be just greater than, and now I have to find this equation. So my y-intercept is 0, negative 2, and my slope is negative 1 over 1. So negative 1 over 1. So I could just write it as negative x. Okay? You could write it as negative 1x if you want. That's fine. Okay? So we have to see it intersects here. Or that's where it's shaded. So it's shaded above this line and above this line. And now we're going to graph some. So we have y is less than x plus 2. So the first thing I'm going to do is figure out if that's a dashed or solid line. Well, it does not include it, so it's going to be a dashed line. So I'm going to go and plot my y-intercept at 2, and my slope is 1 over 1. So up 1 over 1, up 1 over 1, okay, all the way to the end, or down 1, back 1. Okay, and I'm kind of being a little bit more careful with this one because then I have to draw my dashed lines. Okay. All right, and we're shading below this line. So I'm just going to draw a couple arrows there showing me where I shade. So now let's graph the other one. So y is less than or equal to, so this is going to be a solid line, negative 3/4 x. So my y-intercept is at 0. And from there, I'm going to go down 3 over 4. Down 3 over 4. So that's going to go off. But from here, I can go up 3 and back 4. Up 3 and back 4. Okay. So now that's a solid line. It's less than or equal to, so I'm going to draw a couple of these symbols here. Okay, just saying that I'm shading below it. Okay, well, this one and this one are in the same spot, okay, for both lines. So that's where I'm going to shade. Okay. And once again, you could do the same thing. You could plug in a point and see if it works. So here I could plug in, I probably wouldn't want to do 0, 0 because it's on the line. Okay, but you could plug in one from this section, one from this section, one from this section, and one from this section. And there will only be one that's true for both equations. You have to plug it into both, and that's the one that you would shade. Okay, or you can do the little, arrows like I did here and say, oh, look, they both have an arrow here, so that's where I'm going to shade. Okay. All right, so that's it for 1.6 for pre-calc and 2.5 for Algebra 2. I'll see you guys next time.